distinct pleasure for me to be with you. I mean, it's wonderful, actually. Now, I've been away for 8 years. It's not just 3 years, but 8 years. And one of the things I first noticed here in Hong Kong is people are social. You know, they know each other, they're connected, they're integrated, and you know, it's like being a fish in water. You don't really know, but somebody from the outside knows that, you know, fish are in the water. That's what I feel like. I've come into a place where there's so much communication and collaboration and good feelings. And so thank you very much for coming, and I'll just join Paul in saying thank you at the beginning of your vacation days to come in and come to this conference. It's really nice, so thank you very much. What I have in mind is first to welcome you to this meeting and share with you some of the purposes of the user conferences that we hold. They're fundamentally to help you be more successful as professionals, but they're also about building relationships. I like what Paul suggested is people getting up and introducing themselves to new people. But in this particular audience, most of you know each other. Take a moment and look around. Do you know everybody in the room? Okay, how many people you know? 5 people, 25 people, not 300 people. It's interesting. Look, today during the breaks and in the various sessions, I really would encourage you to meet somebody new and tell them why you're here and what you're doing. It's a way of collectively learning. I hope that you enjoy my talk, but in many ways, what you have here, the kind of sharing and collaboration and spirit of that GIS facilitates is something special. So you have a lot to learn from each other. And I can't emphasize it enough. Watching this video and yesterday visiting with some of you in your offices, I am overwhelmed by I mean, you are leaders in smart city movement. Now, I'm saying that carefully because, I mean, I have users all around the world. I don't want you to, you know, create too much jealousy here, but this is really quite an extraordinary, you are the center, I think, of smart city movement, making things real, taking the idea of vision of smart cities and really driving it. So congratulations in that respect. I mean, I'm very honored, of course, to get this wonderful PhD from Hong Kong University. And those of you who helped me be nominated and so forth, thank you very much. But I also am more pleased at what I saw actually in action here in your work. It's fantastic. You're a special group. I've been talking about you. You have different backgrounds. You come with different interests. You have different professional skills, but you also are part of a network of users. There's now about, by my estimate, about 10 million users around the world who are using GIS as a foundation for being able to make a better world. And our users, we may say, are fundamentally addressing all the big challenges in society, in cities, in natural areas, in agriculture, in transportation, in the environment, in business, virtually every field. So you're part of this network. That's what I want you to feel. Just like there's a kind of feeling of community in this room, you need to understand that I get it, who you actually are. You're participating in a massive movement to transform the world. I'll talk about this more in a moment, but I'd like to start by sharing some of your colleagues' work, mostly in other countries. Our users are working on environmental assessment and conservation in the Amazon, tracking illegal forestry cutting, doing work in conservation protection, like setting up green areas, both at national scales and also in cities, looking at bird habitat, looking at issues of pollution, whether it be water pollution or light pollution, looking at airflow modeling. It's extraordinary, the little footprints of work that are going on. In the field of land information, that is what exactly Department of Lands here in Hong Kong does, you are building a kind of societal infrastructure, a kind of foundation for a civil society, property ownership, assessment, being able to do taxation, being able to protect people's rights in owning property. This is amazingly valuable. And there are thousands of organizations like you that are operating around the world. Yesterday I had this most wonderful presentation by Hong Kong Lands Here. And they have automated map production. They have automated transactional updating and maintenance of this fabric. And their plan is to build increasingly a 3D system by integrating BIM modeling, the building information models, into the workflows so that as buildings are built, automatically these systems are maintained. But you are joined by others around the world. I'll call your attention to Angola, who has just finished a massive integrated cadastral system for their country. And so it's not better than, it's not worse than, it's just interesting to see that this is a foundational piece of infrastructure for the world. In urban planning, you are distinguished, and others are as well, looking at change, looking at monitoring of urban planning. In the area of transportation, here in Hong Kong, you have automated almost every transportation flow in the country. And look at these other examples, like the distance to nearest EV charging stations in Germany. EVs are taking over the transportation systems. There's a new kind of operation occurring that is space for moving drones for delivery systems. Both in Europe and in the US, this is quite popular these days. The work in asset management associated with energy companies, electricity, gas, is well known. Being able to manage assets in the field, being able to also work with GIS to transform energy systems into renewable systems. In the lower left, I'm interested in what they're doing in Germany, offshore with wind production, and using GIS to then connect this renewable resource in with the normal grid and empower their grid. We're seeing lots of work in telecommunication, in the area of broadband planning and design, and then assessment of those neighborhoods which have it and don't have the kind of coverage. One of the big issues here is overcoming the digital divide between rich and poor accessing Wi-Fi cableless work. You know, the world is in many ways safer because GIS is providing a foundation for both observing and responding to various issues that we're facing. The picture in the upper left is the head of NATO who's traveling by helicopter using GIS to assess what just happened in Turkey with respect to the earthquake, being able to plan for and then respond effectively. But look again across the whole business here. Hong Kong again should be proud of your fire response systems. This is similar in other cities and other countries around the world. Law enforcement and being able to respond to emergencies of all type, track, for example, illegal fishing around the world, and so on. These dashboards show some of the work going on in health and human services. COVID is, thanks to God, it's over almost, yet we're still monitoring it with dashboards. The Johns Hopkins dashboard was looked at 1.6 trillion times, and it told the world, using GIS as a framework, about this horrible disease and its pattern. It made people believe that the disease was actually occurring. And by the way, the second most heavily used dashboard in the world after the Johns Hopkins was the one built for Hong Kong. I mean, it was very intriguing, very responsive, and I appreciate the good work that's happened there. But in healthcare issues of polio, for example, eradication in Pakistan, or dengue fever in Brazil, GIS is helping visualize and then respond more effectively to this human set of work. In recent years, the engineering community, particularly AEC community and public works, have embraced GIS to build better engineering, being able to do better engineering design, and even on the frontier in New Zealand, we see the ability to use AI and machine learning tools to be able to automatically generate sewer networks in various forms. So whether it's assessment of workflows that need to be done, or tracking workflows, or tracking, targeting issues, looking at the dashboards of what's occurring, GIS is showing the way. Another field that has been emerging very rapidly around the world is GIS applied to buildings and facilities and campus management. Here we see some examples, for example, in Belgium, where we're looking at energy and building performance using GIS visualization, or building space utilization. It's kind of like land use planning, but in a building, and apartment leasing, and it goes on and on. 3D buildings are intriguing because they can be built semi-automatically from BIM files, or now with procedures built from CAD drawings of various types. These are a few examples of this operation happening. In many universities, including my own university at Harvard, they've built a navigation system for indoors, but also between the various buildings, something that, again, I saw yesterday emerging right here in Hong Kong, a kind of new pedestrian network. And this technology similarly is applicable for census. 2 years ago, certainly since we've been together, the US did their national census, and it was almost entirely done with GIS, capturing data, aggregating data, reporting data, both at the address level and then statistically the information outside of it. But so did Ecuador, so did Uganda, so did Ethiopia, so did the Philippines. It's a framework, geography is a framework for statistical reporting and then better understanding. Look, it's largely a public sector business. You know, GIS has largely touched almost every public sector, but it's also increasingly being embraced by the private sector, being able to find the right location. We see some examples of business locator apps, or monitoring supply chains, or optimizing supply chains. And in the upper right, you'll see the ability to do assessments and selection of automobile dealerships in Jacala in mainland China. Imagery in recent years, like we saw from Planet, is transforming GIS. It's providing us more up-to-date and synoptic information. This is a whole spectrum of different types of sensors. LiDAR sensors looking at transmission towers, for example, visualizing industrial facilities with 3D LiDAR assessments, ship monitoring, looking at damage assessments using drones to capture information right after emergency disasters. And then we're increasingly seeing features extracted automatically from various forms of remote sensing. Look, all of these examples are stories. Every example I showed you is a story. It reflects a complex system. These are some that I pulled out of the submissions that our users gave me this year that particularly attracted me. One story is in the upper left. It's by Wejo. These are companies that are related to electronic or connected cars. And so as they brake, the red areas are showing braking, which is traffic congestion in a way. It's a whole new kind of cartography. And the lower center one, it's actually Mecca, a place that is extraordinary. And seeing it in Saudi Arabia, it's sort of opening up Mecca to those who are not Muslim to be able to kind of see the reality there that others can't, seeing what others can't in a way. My favorite, however, is the map in the upper right, which is a Braille map. This was done by the Dutch Cadastre for the first time. It automatically prints out of ArcGIS Braille. And my aunt was blind, so I grew up with this impairment in my family. She's no longer alive, but I really wish she was, so that she could see through maps spatial operations. Like Holland is smaller than Germany, or Holland is to the east of or the west of, or Russia is much bigger than Poland, or this idea that we all take it for granted because we look at a map and we know, but those who are blind don't. So the interviews of people that are beginning to play with this kind of map are really extraordinary and moving. Well, all of these are just examples, and I thought to start off this morning it would be useful to rethink, see what your colleagues are doing elsewhere and what you are actually doing. It's really great work. I'd like to cover 3 more things. The first one is a vision for GIS and where I think it's going. Second, I'll talk a bit about the technology that Esri is doing, and then close with a few last remarks. GIS plays a particular role of linking science to action. It's my simple way to talk with the people that were at the university yesterday who are largely scientists or come from science background or academic background. GIS and geography itself is a way to both integrate sciences but link GIS to action. And this is what so many of you do. You're real, the work that you support, the transactions that are made off of the knowledge that you create is phenomenal. You and I are living in difficult times, and I mean, we're challenged by climate change, we're challenged by many different issues, loss of biodiversity, overpopulation and congestion in cities. All of these are things that are really troubling and may become existential threats. But let me simply say that if we look at all of these problems, for me, the simple way to describe them is that people actually don't understand the complexity of what humans are doing on the planet. And moreover, they, for whatever reason, are not collaborating. Again, I just want to say I was so inspired in the last couple of days here by you because you have some sense of collaboration. My colleagues and I were talking last night. There's something about Hong Kong and collaboration across organizations that's special, and we don't see it in other Chinese cities like to the south or to the north. They're still more sector-oriented or discipline-oriented. And again, you're fish in the water. You don't actually see how special it is to be here. But I'm seeing it in the implementation of things like Lands Department GIS. This infrastructure that you are providing is extraordinary because it will facilitate being able to address many of these issues. GIS and this geographic approach, which I'll introduce you to in a moment, how I think, is creating better understanding, and it's allowing people to explore alternatives and think together, find solutions, reach agreement, and move on. And that is based on the idea of creating agreed upon understanding. It isn't enough just to understand science, but it's more important to agree on what's so. And GIS provides us a kind of language to do this. The geographic approach is a way of thinking. It's also a way of problem solving. And here again, I'm talking about your work. It allows the integration of many types of data, and it also supports this idea of holistic thinking, integrated thinking, seeing the world as one, providing a framework not only for the integration of our knowledge, but also acting on our knowledge in almost every sector, as my slides showed. It reflects complexity. It means for the ESG people in the room, it brings environment together in a spatial framework with economic development and social issues. It is the framework, I would assert to you, for creating a sustainable future. This is no joke. Each of you, in your own way, is supporting this idea of scientific integration. For scientists in the room, geography and GIS integrate all the ologies, the hydrology, the geology, the climatology, the sociology, all of it it integrates disciplines. And for those of you who are administrators in the room, it integrates all the different departments, being lands and housing and water and public safety. It integrates everything, brings them together. And it does this by supporting 5 basic methodologies. The first one, which most of you are quite familiar with, is geovisualization. Oh, making maps, of course. But the second one is more interesting, geoanalytics, creating insights from information. And the third one, for a smaller set, is geodesign, the idea I can design alternative scenarios and understand the impacts of those designs. And then fourth, something that is your language, geocollaboration. We're collaborating around maps as a language, involving all the stakeholders involved in any decision. And finally, geo-accounting. This is about accounting not just for the money, but accounting for all the things that people really care about. The water, the environment, the transportation, the level of school achievement, all of that. So you're dealing with a language, a sort of science of understanding that can affect virtually everything in our future. GIS is the instrument to do it. And it has been designed to collect data, to visualize it, analyze it, plan with it, make decisions, and take it to action. And some of you only do a few of these boxes, and you share your information with other people doing other boxes. But the process is clear. It is, this science of where is a process, or the geographic approach is a process, not just a technology. That's one of the things I want you to walk away from in this room. And this starts with a simple description. Well, what is a GIS actually? You might laugh at me by putting this slide in here because most of you know it, but you see it in your own view. This is my view of it. It is a system, just like a financial information system, just like a human HR system. It's an information system for managing and for sharing and for applying geographic information. And it integrates any kind of data. And it supports almost every kind of application. Again, the digital twin that you are building here in Hong Kong is exactly this vision. It's an abstraction of the city, and it supports every activity. GIS is advancing. It's advancing in many different frontiers. Hundreds of small tools are emerging by powering GIS with better imagery and remote sensing, by powering GIS with better and more interesting analytics, and geodesign tools, and story tools, and interactive mapping. Okay. It's also advancing because it's becoming interconnected. Again, you are the showcase for doing this in an urban city. You're connecting data in projects and in separate departments into a kind of infrastructure with hundreds of accessible data sets in distributed nodes and making it available, like the portal which is making you famous. Integration of data from different distributed services and making it available openly for people to use each other's information and engage the public. This is a whole new kind of pattern. It's different than putting everything into one database in one agency. No, it's a portal that can access and integrate all of you and support collaborative work. That's the big vision. Now, many organizations are doing it. I'm not saying that you're alone in this. They span from Jane Goodall doing this in Tanzania around chimps with native populations, to the whole UN organizing and taking a geographic approach for supporting the SDGs, the global sustainability work that's going on there. And lots and lots, hundreds of different operations in between. So I'm simply saying that this geospatial infrastructure pattern is not unique to Hong Kong, but you are a leader in it in urban implementations. Now, I'll conclude this section of my talk by simply saying your work requires a lot more than technology. I mean, you have great expectations of me, and you should, to drive the technology. But I'll simply turn it around to you, that you, as professionals, are also key, in fact, the most important key. And the skills that are necessary by you is seeing what's needed and wanted, and then being able to create solutions from it, being able to be programmed in your own self to provide valuable services to others, and to think about comprehensive solutions. This is really the bottom line for me in terms of institutional direction for you. It's about linking science to action. So all of these information sets that you manage and use, I would say, are scientific abstractions of reality, no matter what scale. And they will be essential to creating a more balanced, a sustainable future for not just us, but for children and future generations. I'd next like to talk about our work. Perhaps this is why you came to this meeting. It's basically to create tools that support you, help you do your work better. And we do that through products and educational tools, through support work. And both Winnie and Paul have done amazing representation to help bridge the gap between the collective Esri technology work and you. It's an important role. ArcGIS is the technology that we use. It's only one technology, but it supports 5 different markets. The GIS market is the biggest, but also analytics and imagery, simple location services, and increasingly, GIS is being embraced by developers who build apps and put maps in apps of various types. Our design is to have an open and interoperable platform, which is both software as well as software as a service that provides services or applications both as for individuals but also whole organizations. Now, many of you actually are doing projects using GIS, but my view has been the view forever is that GIS is an enterprise system. Again, I don't have to tell you this. An enterprise system is cross-cutting. It's one system accessible by many, supporting integration of the workflows. And I just want to remind everybody that as you're doing your individual work, that you are members of a enterprise system, this whole distributed system here in Hong Kong. ArcGIS supports many apps, desktop apps like Pro, massive mobile apps. We now see our users deploying hundreds or thousands or even tens of thousands of mobile devices with GIS inside of them, connecting the field with the enterprise. And finally, pervasive web apps, dashboard apps, mapping apps, and the like. These apps live within a technical infrastructure which is quite flexible. Very different sorts of implementation patterns. Some people just implement the desktop and that's it. Others use it with a server. Others use it with SaaS. Other people just do web apps hitting servers or SaaS. That's one of the big ideas, is it's flexible. And a portal is the thing that brings it together. A lot of the engineering work that's gone into this is to make sure that it reads any kind of distributed information, CAD data, image data, multi-dimension data, as well as traditional vector information. This is a big deal. So there's now over 250 different native formats that can be ingested and used directly as map services inside of the system. Portals, as I've said now 3 times, are the instrument that allows us to interconnect and access distributed systems, and that's enabling whole new patterns of collaboration. And ArcGIS, because of ArcGIS Online, comes with a lot of living data, data from imagery or elevation. And we are not only as an organization adding more layers for the planet, but also there is now over 55 million data sets that have been shared by our users. So it's not at the level of Facebook, but the concept is the same. I'm building a map, I share it with others, and they can use it. within whatever defines sharing for you. It could just be in your organization, or it could be for the world in general. ArcGIS is advancing. I've mentioned this before. We advance it. We spend about a third of our revenue on making technical advances every year. And they fall into two categories. One is we keep looking at what's happening generally in science and in technology. And then we have thousands of engineers who specialize in different parts of geoscience, visualization, analytics, and the like. And in the remaining time period, what I'll do is go through very quickly some of the key research development areas that you can see this year and what we're building next year. The first one is smart web mapping. Now, most of you know what a web map is, but I want to make sure there's a distinction in your brains about web maps versus interactive web maps. And if you look at the red map, you'll notice that I'm interactively changing the histogram and the map changes. So it's a JavaScript in a browser app that connects to geographic data services. That's what we call a smart map. And the ability to then integrate into that interaction analytics of various types is the direction that we're taking, moving not from the desktop, but complementing the desktop to have exploration tools in a browser. Instant apps are a set of templates that allow me to take a web app and build an app from the web map in a few minutes. So we built simple templates that are available for people to go from maps to apps in maybe 5 or 10 minutes. Very important technology. The third is perhaps the most popular of the apps is dashboards themselves. I need not say a lot about them, only that they are so popular. There's probably in the order of 500,000 of these dashboards now visualizing and running different aspects of government. In my country, the President of the United States looks at a series of dashboards every morning at 7:30, looking at the world. That's the executive view. But a mayor or a city or a department head in a water agency or citizens wanting to know how we're doing in COVID, dashboards are a kind of visualized template. Story maps that are similar, very popular leveraging of web maps by telling stories around them. And this is the big message that we have to learn how to do better. Tell the story of our work and what's happening. The analytics provide the fuel behind this, and there are thousands of analytic tools inside of ArcGIS. These are just a few of the new ones that are emerging in the last year and this next year. In the area of GeoAI, one of the frontiers, in the area of network analysis or graph analytics, very powerful tool, the area of big data analytics. I'll just cover these very briefly. One of my favorite ones is the fact that ArcGIS is getting smarter. That means AI and machine learning and deep learning are being embedded as tools for both creating models, but also using models that other people create. The most popular ones are in the imagery area, but they're also working in text areas and with vector information. We have engineered ArcGIS to embed some of these GeoAI tools inside of the system, like inside of Pro, but we've also wired it up in such a way that they can talk with the complete world of open science libraries, things like TensorFlow or PyTorch or whatever. So it operates almost as a single system. This is being used to automate flows of work, to do massive processing, but also to create new learnings for how we behave with respect to geographic data and the relationships. Lots going on in this field, like the whole ChatGPT. People often ask me, okay, what are you doing with ChatGPT? Sorry, I don't know yet. Well, that's coming, but I just wanted you to make sure that our philosophy is to integrate AI and machine learning and deep learning into the toolbox rather than have it as a whole separate thing. So our users will be impacted directly in the workflows that they're doing. Another area that is interesting to me is the idea of spatial analytics of big data. Here in the last year, we invented a new technology. It's called the Geoanalytics Engine. This is not ArcGIS in the desktop or in the server. Well, it's a library, a special little software library that I can send to a cloud, put right next to where we have big data like data warehouses or data lakes, implement it in a Spark environment so that I can apply GIS functionality to billions of observations like customer information or scientific observational data. So I'm doing spatial analysis, things like spatial aggregation or near proximity work, but in the cloud. I don't need ArcGIS, but I can integrate with ArcGIS. I can use notebooks to be able to run this whole thing or web browsers. But for the enterprise customers, they want some of that spatial stuff next to these big data operations. So the next thing I'll cover in analytics that I think is quite a breakthrough for us is the integration of graph systems with GIS. Another way to describe this is entity relationship networks into a GIS. So we are all entities in this room. This is a way to understand it. And you have relationships with your parents, with your family, with your friends, between agencies. You can graph out how we are interrelated with a graph. What we've implemented is a spatial graph that can be overlaid like another layer on top of the rest of GIS. And this has huge implications for health, for epidemiology, for supply chain routing of trucks and vehicles, well, crime analysis, you know, where are the bad guys, how are they connected? This is interesting work. I can't tell you very much about the applications, but they are exploding in the user community. This is largely new technology, and it's going to be up to you to experiment with it and make it more real. Real-time visualization has been also getting better. We've had operations in R&D for about 11 years on this with software called the Geo Event Server that connects to IoT or real-time data and visualizes it. Now we're moving to the cloud with SaaS operations that help visualization, analysis, alerting, and managing of very large real-time data. Think of the connected car environment of all cars here in Hong Kong being able to be connected in real time. 1 million observations a second can be brought in and visualized and analyzed with respect to traffic or any kind of IoT in building and so on. Next, I want to emphasize that ArcGIS at the development level is supporting your vision of being a complete 3D system. We have historically been a 2D system with transactions updating the 2D systems. This diagram represents what, in a way, you are doing here, the idea of integrating everything in 3D, 3D BIM models, for example, 3D urban plans, updating and viewing an integrated 3D city, people in the field, looking underground, all of it, for operations, for planning and management. This vision is driving a lot of the lower level development tools, and you'll see increasingly more of this over time. One of the biggest revolutions is the integration of 3D vector data on the left, features, with 3D meshes on the right, captured from drones or captured from a variety of different sources. Let me just sort of make that a little real. This turns out to be Vienna, Austria. This is a 3D mesh that was captured from aircraft, processed in a few hours. This is the UN complex of buildings here in Vienna. And you can see it's just beautiful. Ladies and gentlemen, this is a 3D picture. I don't know if you've ever seen a 3D picture. Well, I'm sure you have. This is similarly a 3D picture in Utrecht in the Netherlands, but this 3D picture has been integrated with 3D BIM data. This is the full representation of BIM. And together, they represent pictures, raster, and vector. Look at this BIM being constructed over time. And this is using the indoor software. I can look at room planning, do navigation inside of buildings, etc., in real time. So BIMs are a transaction on a 3D system of record. Another way to describe this is that the 3D pictures are what is known as reality capture. You fly an aircraft or you fly a drone, you run it through the software, which is digital photogrammetry, and it creates true orthos or creates orthophotos or survey quality information products that can be used directly inside of a GIS. Are you understanding what I'm talking about here? This seems like you know, a lot of stuff, but it's quite simple to do. And you are already experimenting with this here in Hong Kong, but I have great expectations because this will currently runs with drones and aircraft, but it will soon work with satellite information where we have stereographic overflights from multiple satellites. This is again Utrecht, the same little Dutch city I showed before with BIM models, but I want to just take you on a tour of Utrecht, and you can see again I flew the aircraft with overlapping photos. I put it into a computer, and in an overnight session it gave me this beautiful 3D picture. I mean, isn't that extraordinary? I can almost see people running around, you know, or food on the table. It's not at the scale of leaves, but look at the articulate buildings here, or actually in that cathedral with these big flying buttresses, I can see through it. This is a 3D picture. And being able to integrate the 3D picture with vector information is profound. So let me say, this is Utrecht again, but this is the 3D vector information underneath it. So I just put the 3D picture on top of it like this, boom. Now I have the vectors underneath the 3D picture. So I can again fly around the smart city, and I can have that same visual effect of my 3D reality. I could fly this every week and show a new picture of changes on top of the vector. And I could type in, show me all the government buildings, and boom. Or I could point at this particular building and say, do a query and identify, you know, who owns this particular building? So it's the combination of raster and vector, same story that we did in 2D for forever, but this is 3D combinations of exactly the same notion. This will open up and make more accessible a lot of the 3D GIS work that you do. We're making lots of improvements in 3D to support this 3D GIS, new tools for 3D editing, more integration of BIM information, new visual effects, and also the idea of supporting game engines accessing the 3D system of record. And we saw some out in the hallway coming in. I noticed some of the partners here of Esri Hong Kong are doing this already. This is done by supporting the connection between GIS directly from game engines. It's like a plug-in to Unreal and Unity. So I have the AR, VR experience of a game engine, but it's accessing the 3D GIS. Same sort of things that so that means I can open up for the gamers, for the people who want to do animation or special effects, or citizens to actually experience in a more realistic way the 3D cities that you're building here. Let me show you this example in Gothenburg in Europe. I'm flying through a game engine visualization of GIS data. Isn't it beautiful? I mean, okay, this is a little different setting. Or here's the downtown where I'm looking at buildings and seeing the information in the buildings, but I'm adding physics models to move people around, you know, for better visualization. And this can get better and better. You'll see some more of this soon. Or using game engines as a way to do spatial interactions, for example, between different dynamic areas within the city. It's showing flows, relationships, patterns that can make the city come alive in virtual ways. Or if I wanted to look to the future and say, let's simulate heavy rains, a monsoon rain or a typhoon hitting, what is it going to look like so that normal people can appreciate better what this 3D GIS city is really all about. All of this, I think, is now available now. It just is the creative starting to think about how we actually use and leverage that information. The final sort of media connection I want to mention is this integration with imagery. I've said it now a number of times in my talk. ArcGIS is a complete, comprehensive image system. It has the components to manage large amounts of imagery, hundreds of images, thousands of images, millions of images in a data management system. It has those tools to be able to make automatically maps from the images, like the reality capture technology you just showed. It has tools to do imagery analytics, classification, GeoAI, and of course, image visualization. All of this is transforming GIS, actually, by integrating remote sensing more closely and in a more integrated way. It really makes it come alive. And part of that is drone capture. It's not just aircraft, it's not just satellites. I can now very inexpensively have a drone, fly it on a construction project, and have the processing of all those imagery done automatically in a desktop or in the cloud, creating exactly the same survey level quality outputs that go right into a GIS. So in other words, drone flights are a kind of transaction, monitoring transactions on my 3D city or system of record. This is fun. I hope you get excited about this. For me, it's like opening up for, you know, a few $1,000s. I can buy a drone and fly it like this, and suddenly for engineering projects or road projects or monitoring projects, changes the game. For some time, we've invested in connecting field workers with GIS, and this year particularly is massively growing. We're seeing, as I mentioned before, big utilities implementing this with thousands of utility workers to not only be fed by GIS data, but also collect GIS data. ArcGIS field maps, survey 1, 2, 3 for the statistical data collection, and even quick capture is empowering and enriching the enterprise with updates. In other words, every field worker is a sensor. That's the way to think about it. So again, next step. The last integrative technology I'll talk about is the work we've been doing, pioneering with Autodesk Corporation, but we've been expanding it beyond just that company. Autodesk is a strong partner for us, and they opened up their data structures so that ArcGIS can actually read in ArcGIS Pro, not Map, but Pro, can read directly BIM information, like Revit information. And by being able to read it in Pro, I can then also right-click and turn it into a service inside of ArcGIS Online or inside of enterprise implementations. Do you understand what this means? It means that the BIM data can be visualized inside of ArcGIS, but also that BIM information can be overlaid with other layers inside of ArcGIS. So this work that I saw yesterday at LANS was amazing. In part, can be facilitated by being able to have these large cloud repositories of BIM information that get integrated dynamically with living GISs. The second area of work has been to be able to take the engineering tools in Autodesk and have them geospatially enabled by the same smart maps that I introduced early. So I can be an engineer working in Civil 3D or InfraWorks and read in the GIS maps underneath it as base maps to give me guidance in my engineering work. And finally, a new technology called BIM, or GeoBIM, is the ability to read BIM documents, like a complete BIM file, and link them to GIS features. So I can bring them up side by side and look at the relationship between features and the BIM drawings. There's lots of civil engineering applications that this supports. Look, I've covered a lot of technology that is all about ArcGIS. We do also work in the product world. So we actually put all of this capability into one product. It's ArcGIS, but that shows up in Pro and Online and Enterprise and the like. So Paul mentioned already that Pro is our strategic direction. There are already over 1 million users of Pro. It's a modern desktop application. It reads services, creates services, and is integrated in with everything else. You can look at what's coming here this year, more enhancements. And Pro has many extensions, now including the reality mapping extension for mapping production, now including ArcGIS Knowledge, which is this graph database connection technology, and other tools, of course. The second leg on the stool is ArcGIS Online. This now has over 10 million users who are creating, using ArcGIS Online as a SaaS operation, and lots of new enhancements here coming as well. The third technology implementation is Enterprise. This is ArcGIS's server. This is for managing systems of record, but also in an on-prem environment, building apps of many different types. There are hundreds of thousands of servers now implemented around the world, and they are providing services that can be mashed up with portals for accessing distributed systems. Our work here has been implementing ArcGIS Enterprise and Kubernetes. So some of you know what Kubernetes are, some of you don't. So ArcGIS runs in Windows on a server. ArcGIS also runs in Linux on a server. Now ArcGIS runs on Kubernetes in a cloud. So Kubernetes is best thought of as a kind of operating system for cloud native. And it divides up the software into microservices that can scale out enormously. There are now about 400 implementations of the Kubernetes system. So those of you who have very large databases and very large number of users may look to having a almost infinitely scalable cloud native version of ArcGIS Enterprise. Lots of work going on here. Beyond the core products, ArcGIS products, we also have a series of geo-enabled products. These are application areas or specialized focused areas which are built out of ArcGIS but support specialized workflows for indoors, for urban planning, for business analytics, for mission planning operations like law enforcement or emergency management. The only thing I will say about these is this is likewise an area of rapid movement. And I haven't seen as much adoption in Asia of these yet, but I would encourage you to look at them because they're in a way extensions to your fundamental operations in various organizations. Look, we're very active in 2023. We'll spend nearly $500 million on new R&D this year, and it'll be in the form of enhancing or evolving each of the platforms I've been talking about. These are some of the big areas. One of the purposes of this meeting is to get feedback from you. So my colleagues are here. They would like to hear from you, if there's a problem with our tools, or if you have an idea, why don't you add something to it? Like there are people in this room that had major impact on our technical direction over the years, and so don't be shy about giving us ideas or showing us what you think we should do, and in that sense we are in service to you. Esri, as you know, is a several billion-dollar operation around the world. Our main core mission is to build great tools that help you. That's how we think. We're not a public company. We keep it closely held because it is a services-focused organization. So thank you very much for the support for this. It's been really an amazing adventure. Our other missions are, we're interested in spatial literacy. This is why we're intrigued by pushing in schools the use of our tools. This summer we'll release a number of new initiatives around growing the spatial literacy of K through 12 schools as well as universities. We also enjoy this idea of a partnership, and again, I want to simply say thank you for the partnership in that regard. I wanted to get across the idea that GIS and this geographic approach are advancing. They're not just advancing technically, but people are starting to wake up to the power of it to address some of these great challenges that we're facing. And the opportunities for you, for your organization, for young people in the room to get inspired and make a difference with this kind of technology, I think is just beginning. So let me say thank you again, wishing you great blessings from where I sit, and I want to say thank you for this, again, very wonderful honor that Hong Kong University provided for me yesterday. And I'll look forward to spending more time with you. You're all invited, by the way, to come to San Diego this summer in the middle of July. Some of you have been there, you know the value of it, so thank you very much. Thank you for everything you do.